This video is going to walk through how to answer the questions on this concentrations and dilutions worksheet. So I'd advise you to try the worksheet by yourself first and then watch the solution to see how you did. So for the first question here, number 1, we are asked to calculate the molarity of a solution prepared by dissolving, and we're going to be dissolving 0.75 moles of sucrose into 0.45 liters of water. And so remember, when you think about molarity, that's a capital M, and molarity is defined by moles of solute divided by the volume in liters of our solution. And so for this first problem, all we have to do to find the molarity is we're going to take this 0.75 moles and we're going to divide it by our volume, 0.45 liters. And so we can go ahead and divide that out. We can show it on the calculator if we want. So we have 0.75 divided by 0.45 equals 1.6666. Looking for sig figs. We want 2 sig figs. So I'm going to call this 1.7 capital M for molar. So there's our answer to the first question. In number 2, we're asked what is the molarity of a solution prepared by dissolving 2 grams of sodium chloride into 15 mils of water. And so again, what we want for molarity is we want moles divided by our volume in liters. In this case, we're starting with grams. And so this is a case where the first thing we're going to have to do is actually convert from moles to grams. So we actually have to do a conversion first and say, let's start off with our 2.0 grams of NaCl. And what we then need to do is convert grams into moles. And so we know there's 1 mole for every 58 grams of, and this is for sodium chloride. And this number, this is our molar mass, which we had to get from the periodic table. So I skipped that step, but we should be able to go back and double check that we can add up the molar masses. And so we can calculate the number of moles. So I might pull my calculator back up and clear it out. We have 2 divided by 58. And so we get 0.034 moles. Now, once we have the number of moles, we can think about putting our moles into our equation here. However, we need to know the volume of water in liters, and we are given the volume water in milliliters. So what we might want to do is convert that 15 milliliters. We have to go to liters. So there are 1,000 milliliters in 1 liter. And so we end up with 0.015 liters. And now we can find the concentration of sodium chloride, the molarity, of 0.034 moles divided by 0.015 liters. We can multiply that out. Put my calculator over here, 0.034 divided by 0.015 equals, and we want 2 sig figs, so 2.3 molar. Okay, one of the great uses of concentration is it's another way we can use it to find the moles of something. And in this case, we were asked to calculate the number of moles of sulfuric acid in a 2-liter solution that has a concentration of 18.5 molar. So again, if we think about what we were told, molarity, again, is moles per liter. And so what we know here, if we think about what we're given, this is our M, and this is our volume. And anytime we're given a concentration and a volume, if we think about our formula here, if molarity is moles per liter, if we multiply that by volume, we get moles. And one of the really important things to remember is that basic idea. Concentration times volume equals number of moles. And that's again because molarity, moles per liter times liters equals moles. So those two statements say the same thing, but it's just a really crucial thing for us to understand. And so what we can do here is we know we have 18.5 moles per liter. So that's our concentration. And I'm going to multiply that by the volume, 2.00 liters. And notice liters go away, and we're left with moles. And so I can multiply it out, which is just 18.5 times 2. We get 37 moles. And actually, we can take that to one more sig fig, so it'll be 37.0 moles. So in question 4, this question, we're going to prepare a solution of known concentration. This is a really common problem in any sort of wet chemistry lab, whether you're biology lab, chemistry lab, environmental studies lab, where you have to make a solution of a particular concentration. And so in this case, we're asked with preparing 2 liters of a 0.5 molar solution of glucose. And so if we want to think about how to do that, what we really need to know is what mass of glucose do we need to dissolve in 2 liters of water so we end up with a 0.5 molar solution. And so to answer this question, I've broken it into 2 steps to help us. And we're going to start off and figure out how many moles of glucose do we need to make this solution. And then how many grams of glucose do we need. So we'll start off with moles. So if we want to figure out how many moles, we know we need 2 liters of solution. So we're going to multiply that 2 liters by our concentration, 0.50 moles per liter, right? And if we do this, we find out we need 1.0 moles of glucose. So then in part B, we're asked how many grams of glucose are needed. So here, we now know the moles, so we're going to take that from above. 1 mole of glucose is what we need. And then what we're going to do is we're going to multiply that by the molar mass of glucose, which again, we're given in our problem. And so this is 180.256 grams per 1 mole. And in this case, we're going to be left with that 180 grams glucose. So what is this problem saying? If we want to make this solution, we would dissolve 180 grams of glucose in 2.0 liters of water. And this is actually how you would make that solution in the lab. So in part 2, we're dealing with dilutions now. And whenever we deal with dilutions, it's good to remember our dilution formula. And the dilution formula is M1 V1 equals M2 V2. And so in this first question, we're told in the lab, we're going to pipette 2 milliliters of a 12 molar solution of HCl into a new beaker and then dilute it to 25 milliliters. So what we want to know first is how many moles of HCl are removed from the pipette. This is really M1 V1 of our equation. And in part B, what is the final concentration? This is solving for M2. Okay, and so when we think about how many moles are removed from the pipette, we're just going to take we took 2 milliliters. Now, we have to be a little careful. We're given milliliters, so I'm going to convert that to liters by dividing by 1,000 liters. And I'm going to multiply that by the concentration of 12.0 moles per liter. And that's going to give me the number of moles of HCl. So if I multiply that out, I get 0.024 moles of HCl. And so what we just did was we solved for this portion of our formula, 0.024 moles. So we took a pipette, we sucked up 2 milliliters, and in that 2 mils, this is the number of moles of HCl. We put this number of moles of HCl into a new beaker and then dilute it until we have 25 milliliters. So now we want to find the final concentration. Well, concentration, in this case, M2, our final concentration, is going to be moles over volume. And that's going to be 0.024 moles over our final volume, which was 25 milliliters, or 0.025 liters. And so when we multiply this out, 0.96 molar. Now, there's our answer for the question. I just want to show you a shorter way of doing this problem. We broke this into 2 steps, but another way we could do this, I'll move this over here. Okay. If we just started out with our dilution formula, M1 V1 equals M2 V2, what we see is what we're solving for is M2. So if we rearrange our equation, M2 is equal to M1 V1 over V2. And here we can start plugging in. We know our M1 is the 12 molar. V1 was the 0.002 liters. And that's divided by our final volume, which is 0.025 liters. And M2 is going to equal, to show you all this on a calculator, we can pull this up and say 12 times 0.002 divided by 0.025, 0.96 molar. As you can see, we get the same answer. It's just all done in a single step. And so that's how we can solve this next one. Here, we're asked if we have 4.12 liters of a 0.850 molar solution of phosphoric acid, and this is diluted to a volume of 10 liters, what is the concentration of the resulting solution? So again, we're going to use our M1 V1 equals M2 V2. And over here we can say M1 is our initial concentration, 0.850 molar. V1 is our volume of that we're using, 4.12 liters. V2 is our final volume, in this case 10.0 liters, and M2 is what we're trying to find. So we're going to rearrange our equation. M2 is equal to M1 V1 over V2, and then we can substitute in 0.85 molar times 4.12 liters divided by 10.0 liters. Watch our units, liters go away, and so we're going to be left with a concentration. Pull up our calculator, clear it out, 0.85 times 4.12 divided by 10, 0.350 molar. And there is our final concentration. Notice we can ask ourselves, does it make sense? We are less concentrated than where we started with, which hopefully makes sense because we added water. So we should have less stuff per unit volume, a decrease in our concentration. Thank you.